a frequently asked questions, one of the frequently asked questions, load balancer. Please be focused on this. If you have any questions, do ask. Do the practical. I have observed that many few of you have done the UDR practical. NSG you guys have done, but user defined route, I see hardly few replies. I have got screenshots. I have got. I checked. They were correct, but maximum of you have not done that. So it's a request, guys. Please do that. It is an important topic. But when it comes to load balancer, very important topic. Do not skip that for sure. Right, so let's get started. First thing, I'll read the definition for you. I'll explain it to you. The interview questions, I'll explain that to you, and then we'll go ahead and perform the practical. I am expecting that to be done in the one session today itself. If not, we'll do this tomorrow. So what is a load balancer? I have already explained a three-tier application to you. People who have missed, go ahead and watch the video, please, once, and you will have some understanding. Three-tier application. Why am I talking about it now? Because when we talk about load balancer, we'll uh, talk about internal and external. So when we use it, you should have a little bit of an understanding of three-tier application. Okay, so let's get started with load balancer. What is a load balancer? Load balancer is a service from Azure, which Azure offers under load balancing. Don't get confused. Look at my screen. Load balancing, it's a technique. It's a thing which we need. Load balancing is nothing that forwarding your traffic to active servers or to usable servers. Let me open Paint and I explain it to you. Let's say that for one application, I have 10 servers here. It could be under availability set, availability zone, or without any availability set or without any availability zone. It could be anything. But let's say that I have these many servers for one application. I'm just hosting one application on this one. So it doesn't make any sense that I have 10 servers, but I'm asking all my users to connect to them differently, individually. Right? That doesn't make any sense. Let's say these are my users. If I ask all the users to connect individual server and different servers, then there is no high availability. I mean, if this user is connecting, if this user is connecting to this server, and this user is connecting to this server, this user is connecting to this server, this is no high availability for me. Why? Because if this server goes down, let's say these three users, not every user won't have one individual server. So even if I have something like this, so if this server goes down, if let's say this server goes down, then where is the high availability? Because these four users had only this server's address, right? So there is no high availability. So what my load balancer does is, my load balancer gives me an option to route the traffic. How to route the traffic? So what it does, it gives one point of contact, so all users can connect here. But this can be achieved using some other service also, like DNS, etc. I can do that. Why do I need load balancer here? So DNS or other service, what they can do maximum for you is they can collect all the traffic here and then send it back. But then they don't know what is happening at the back end, whether servers are up and running, whether they're running or not, what is the traffic on them. They don't know that. Right? So that is not a useful solution for me. So looking at this one, sorry, what it does, it takes all the traffic from here and it divides the traffic to other servers, and then it divides equally. It will not happen that all traffic's 80% traffic is going to one server and only one request is going to other server, and remaining servers are empty. That is not going to happen for sure. Got it? So when we use load balancer will make sure that all servers are being utilized equally. So if one request was sent here, next request will be sent here, next request will be sent to here, next request will be sent here, another request will be sent here. So this is how it is load balancing the traffic. And this is not only thing which this load balancing is doing. Load balancer also knows there are some methods. Now we are going to see that load balancer also knows that which server is down. If this server is down, load balancer is not sending any traffic here for sure. It is not sending any traffic here. Got it? If this is down, if this is down, and when I say server is down, it's not necessary that your server needs to be shut down. If I have a server, a web server, maybe server is on, but the web application on that application is down. That application is not working. If that application is not working here, this is also considered as server is down. My server actually it is running, it is not shut down, it is up and running, but my application, my web server, or that service is not working. For example, if we use any website, we use it on port 80. If the port 80 is not working on this server, load balancer will consider this server as a down, and it won't send any traffic. It will send traffic only to live servers, and it will divide the traffic among the live servers. That is what a load balancer is. Any doubts anyone has in this explanation? Yes, guys, yes, no, maybe. Are you getting it? Not getting it? Only this explanation. Future questions, I am explaining it to them. Don't worry. How
No,
to do
sir.
that? Okay, great,
Good. We are good.
great. Look at this. This diagram also representing the same thing. These are users. They're connecting to load balancer. Load balancer is dividing the traffic. This is how it works normally. Okay.
Sir.
Now, yes.
Load balancing is pinging every 10 minutes, every seconds, or it's
I just told you,
pinging.
Satish, that we are
Okay.
going how to configure that. I'll cover that. Don't worry. Any
Selvi,
confusion in this one? How are we making
Selvi,
sure that how load balancer will come to know what is up, what is down, in how much time, what is the interval it is taking? We are going to learn that all. Don't worry. And right now, just after this question and answer, we are going to start that. So any questions in this explanation, whatever I have explained till now? Any questions on this? Sufyan, were you asking something?
yes, Selvi, if the server is down, it divides the traffic equally, right?
Irrespective of server down or not, it will divide the traffic equally among the
Okay.
responded servers. If all servers are up, it will divide in all servers. If out of 10, 5 are down, then it will divide the traffic in 5 servers. It is definitely not sending traffic to server which is not responding. Clear? And these servers, they can be individual, they can be in availability set. I'm sure by now you know what is availability set. They can be in virtual machine scale set. I hope you haven't forgotten virtual machine scale set. Right? If you guys remember, I've told you that time also that availability zone, availability set, a virtual machine scale set. All of these we are learning in isolation, but when we have to use it, we'll have to learn them in combination with some other service. So now imagine that VMSs with load balancer, and then only it will be useful for us. So these are called backend servers. Let me explain that to you now. So if you guys do not have any questions here, we'll proceed. Okay. When it comes to Azure, say this is load balancer. This is very high level detail of load balancing. So for load balancing, Azure has 4 services. One is application gateway. It is a type of load balancing. Another one is front door and CDN profiling. Netflix and other OTT platforms, they are using CDN. Most of the time they use CDN. Okay, so front door or CDN profile, that is also a part of load balancing. Then traffic manager, that is also a part of load balancing. And there is a service called load balancer. It is also a part of load balancing. So what are we learning now? Load balancer, because this is frequently asked questions and this has most options. So I won't be explaining all of these to you. Maybe, sorry, maybe I'll explain all of these, but I won't be able to do the practical for all 4 of these, right? I will explain one to you. I would expect you to do the remaining of them practical if you want. That too, if you want. If you don't do it, that is also fine. But in terms of theory, you definitely should know what are the differences. It is a must ask question that have you worked on load balancing? Yes, I have worked on load balancing. What are the types of load balancing do we have? So you should know we have application gateway, we have front door, we have load balancer, we have traffic manager. Immediate next question you will expect is what are the differences between them? So the differences, I have clearly given you a table. I don't mind you guys cheat with this. You take a printout, you write it down, you open this OneNote in front of you in your interview, as far as they are being done online. Nowadays, companies, they have started calling offline. So we have to finish this very quickly if you want to take the benefit of online interviews. We'll have to finish the sessions quickly and start with your interviews. So I don't mind you mug it up however you want to do it, but you should be able to speak the differences. Now, what are the differences? Irrespective of your understanding, if you don't understand what does it mean, it's okay. I'm not asking you to spend time on that, but you should know, because your interviewer, it's not asking you to explain what or these components are, but he's expecting you to know the differences. So the moment they ask a question, what are the four, or they won't even mention a number. Have you worked on load balancing in Azure? What are the different options and what are the differences in them? One question, you will have a big answer. Yes, I have worked on load balancing. What is load balancing? I just explain it to you. You have to explain this to them. Then we have four services in Azure for load balancing. One is load balancer, one is application gateway, one is traffic manager, one is front door. It doesn't necessary that it has to be in the same order. It can be in any order, it's okay. What are the differences? So load balancer, it is a network load balancer. When application gateway, it is a web traffic load balancer. Now, if you don't understand what is a network load balancer, what is a web traffic load balancer, it is completely fine. No one is going to ask you. Traffic manager, it is a DNS based traffic load balancer. Front door, it's a global application delivery. Okay. Load balancer, it works on layer 4. Application gateway works on layer 7. Traffic manager works on layer 7. It supports, application gateway supports HTTP, HTTPS. Traffic manager supports DNS. Front door supports HTTP, HTTPS. We have types internal and public. Here we have types internal and standard and WAF. WAF stands for uh, web application firewall. Okay, and in front door we have standard and premium. Traffic manager, we do not have multiple types. Routing methods, we have hash based, source IP affinity. Under application gateway we have path based. Under traffic manager we have performance, weightage, priority, geography, multi-evolve subnet. Under front door, we have latency, priority, weightage. Now, I told you guys, we are not going to spend time and I'm not going to explain all of these to you, and you don't even have to understand. But what you need to understand is you should be able to explain at least how many points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think more than 10 points are there. So you should be able to say at least 5 of them. Choose your own 5 points, whichever you think is easy, whatever you like, create your own table, but you should be able to give this answer. If you're not able to answer this, then it's sole and whole your mistake. This is my guarantee. No one is going to ask you and explain what do you mean by layer 4. Do you know layer 4? No one is going to do that. Don't worry. One or two exceptions are different thing, but majority, no one is going to do that. So even if you don't understand, you should be able to say it. Load balancer works on layer 4. Application gateway works on layer 7. Maybe I'll show 2 of them. Today we are going to cover load balancer for sure. And if time permits, if time allows, or maybe sometime later, I may show you application gateway, or I'll show you load balancer, you do the application gateway. Okay, so you should be able to say this. Okay. Endpoints, what are the endpoints? Uh, Endpoint monitoring methods. It has health probe, it has health probe, it has get request, it has health probe. You can talk about this. Redundancy, load balancer has zone redundancy, it has zone redundancy, it has some resilient to regional feature. And if it is difficult for you, don't go into this. Remember easiest one, SSL and termination. Load balancer doesn't have SSL TLS termination. Application gateway has it. Traffic manager doesn't have it. Front door has it. Now, what is SSL TLS termination? Don't worry about it. WAF, web application firewall. Load balancer doesn't have it. Application gateway has it. Traffic manager doesn't have it. Your front door has it. Choose your easiest one, whichever you like, whichever you think. Do not skip network protocol. Make sure that you talk about the layers. This is important. Service, layers, and SKU. These are important. Apart from this, choose any two. I'm asking you to remember at least 5 of them. Not remember, open it in front of you, write it on your palm, write it anywhere, wherever you want. But you should be able to say it to your interviewer. That is the only expectation I have from you guys. So at least 5 points. Load balancer, application gateway, traffic manager, front door. 5 points. Service, remember this. It's very easy. Network protocol, it's very easy. Type, I leave it up to you. SKU, yes, you do make sure you remember this. Pricing, I think it is very crucial point. So you can just remember the pricing. And any point you pick, up to you. Recommended traffic, yes, maybe you can have this recommended traffic. That load balancer is recommended for non-HTTPS traffic, where application gateway is recommended for HTTP traffic, HTTPS traffic. So you can remember this. However you want, you guys do it, but make sure you have this answer ready with you. Is it clear, guys? Did you guys understand this?
Yes.
Yes, sir.
Okay, so don't worry, do not even spend time to understand what is hash based, what is affinity, what is path based. But when we do load balancer, most of these things will be clear to you. And you do application gateway, most of these things will be clear to you. I'll just quickly tell you, by the way, when I say web traffic, that means that I can use application gateway only for those resources where I have website. I cannot use application gateway if I want to do this for RDP. On the other hand, on the other side, load balancer, I can use it for web traffic also. I can use it for RDP also. For example, let's say that for these machines, I want to have load balancer and I want to use these users to use these servers just for website, one application, website application. Then I can use load balancer or application gateway both. But I want these users to take RDP also, and I want in the same manner. They will take RDP to one public IP and it will go according to availability, etc., etc. So this cannot be achieved on application gateway. This can be achieved only on load balancer. So this is what it means, that web traffic and load balancer, this is network load balancer. So, but you don't even, if you don't understand, that's fine, but you should be able to give these differences. Okay, now let's talk about load balancer. Now load balancer is, under load balancer we have SKUs, and now we have seen SKUs standard and basic. So please make sure that you remember them, at least few of them, 2 or 3 differences out of them, please remember them, right? Load balancer types, what are the types we have under load balancer? Now I'm not talking about the load balancing services. Now we are moved to load balancer. Okay, out of, look at this icon. This icon represents load balancer. If you go to Azure portal, under load balancing, this is load balancer. So under load balancing, now we are talking about load balancer. So what does the load balancer is? What are the options? We have internal, we have external. Internal load balancer, when will we use? I explained it to you, 3-tier application. So let's say backend, front-end tier wants to speak to backend tier, and there also you want high availability, then you can use internal load balancer. Or I have an application. Let's take the same example. All these servers are hosting a website which is accessible only for my employees. Let's say that this is a company, UT-Kloud. I have 2,000 employees and I have a website where they apply leaves, where they apply holidays, half days, where they fill their appraisal form, where they where they download their salary slips, where they declare their tax, everything. But how is it happening? All the users are internal. They are doing it from internal PCs. I have not allowed them to do it over the internet. So whenever you come to my company, my location, you log into my laptop, my PC, and then only you can access this one. So in this case, you don't require an external load balancer. You can deal with internal load balancer. But the moment I say a website like Amazon, Flipkart, or anything, or it could be same website, but here I'm allowing my employees to access it over the internet. So I will require an external load balancer. This is the only difference we have, internal and external. Got it? Yes, guys, is it clear? When will you use internal load balancer? When will we use external load balancer? Yes, no, maybe, any doubt, guys?
So, Sohail,
Yes.
in internal load balancer, there is no concept of public IP, right?
We'll come to that. Don't worry. We'll come to that.
Okay.
What are the differences? We'll come to that. Is it clear? When are you going to use internal and when are you going to use external? Is the basic thing
Yes,
clear?
yes. Yep.
What about others, guys? Is it clear?
Yes.
Okay. Then we have SKUs, we have basic, we have standard, and nowadays I think we have one more gateway. This is my old notes in OneNote is not that updated. It's always a good thing to refer portal. So I think we have basic, we have gateway, we have standard. Okay. Now differences they may ask. Gateway, leave it. We are not going to discuss gateway. Again, they may ask differences between the SKUs. What is the difference between basic load balancer and standard load balancer? Why should I take basic and why should I take standard? So look at this. The basic one is free. Standard is chargeable. Chargeable based on the rules. 5 rules are free. First 5 rules are free. Now don't worry what are rules. As of now, we are just understanding the high level. I'll show it to you what are rules, etc. But understand the difference between them. Basic is free. Standard SKU is chargeable. Okay. Charges are based on rule. A few more differences are there. Here it is. You can remember a few points from here. The basic one supports only HTTP and TCP. Standard supports TCP, HTTP, and HTTPS. Okay. The basic load balancer, when we talk about load balancer, I told you these machines, they can be single machine, they can be virtual machine scale set, they can be availability set. But this benefit you get when you have only standard load balancer. If you go with basic load balancer, then your all machines, they have to be in one availability set. Without availability set or scale set, you cannot use load balancer. If you go with basic, and maximum machines you can have at the backend, they are 100. These machines can be 100 in basic. But the moment you go to 1000, it can be any virtual network. It can be any virtual machine. They can be a part of availability set, availability zone, virtual machine scale set, or they can be individual. That is fine. And you can have 1000 instances when you go to standard. Availability zone, does it support? No. Standard, yes, it does support. Rest everything, it's okay even if you don't worry about them. One important point, SLA. If someone is giving you something for free, then there has to be some replication. Azure is not taking any guarantee of your load balancer. What is the availability of that load balancer? Because you're using basic, it is free, there is no guarantee. Maybe all your machines are on and your load balancer is when it's down, right? That could happen. So your services are down now. There is no guarantee. But when you take standard, Azure is promising that 99.99% of your high availability or your application availability, Azure is promising. Now, why would a load balancer go down? Why do you think? What do you understand by the way, load balancer? Is it a PaaS service or is it infrastructure as service? What do you understand by that, guys? First thing, is it a PaaS or what is it?
It seems as a
I think
PaaS
it's
service,
a
platform
infra
as a
service?
service.
Sorry, I didn't get a single answer. Is it PaaS
I
or
think
is it
it's a
infra?
PaaS service.
Infra service?
No, wrong. Yes, it is a PaaS service. Now tell me, guys,
Okay.
all these things, all these features I'm talking about, how do you think it is working? What is a load balancer? What is behind the load balancer? What do you think it's there behind the load balancer? On what a load balancer works?
Availability of the server or the resources.
No, what I
There is
meant that
mechanism behind this.
yes, on what is it working on? Is it working directly on this portal or what is it doing? How Azure is making this load balancer work? What is it using behind the load balancer? Any idea? Any guesses?
I think there must be a virtual machine or
Yes,
a server
perfect.
on
Yes,
which there is a load balancer.
everything behind everything, guys, every service. Even if you are using it as a PaaS service, it's okay. You are not deciding which server is there, but there is a server. If you guys remember on day 1 or maybe day 2, I shown a joke that serverless computing, and if you remove the mask, behind that there is a server. So even if I select a load balancer here, I'm not selecting that server, I'm not managing that server, I'm not deploying that server. This is the reason this is called batch service. But that does not mean that there is no server. ये load balancer भी जो है ना पूरा किसी server पे ही हो रहा है. On some server, Azure has prepared this, and Azure is giving this service to you. So ultimately, behind the scene, there is one server. Though you don't have to worry about it, you don't have to upgrade it, you don't have to select the size, OS, networking, nothing. You don't have to worry about it. Azure doing it. But if there is a server, there are chances that it might go down. That is the reason there are chances that you may have some failure. And when you take basic, there is no guarantee of the SLA. But when you take standard, 99.99% chances are there. So what they will do, they will have their own availability set, their own availability zone. Maybe for one load balancer, they will keep 5 servers. So as a user, I get maximum availability. Is it clear, guys?
Yes.
Yes.
So you are not doing anything, but understand behind every service, there is a server for sure. Without server, even Azure is not dealing without server. So we are clear with SKUs, we are clear with these differences. These SKUs, remember few points here, SLA, etc. Okay, then what else we have here? Yes, few things. Load balancer is one of the services for efficient traffic distribution. This service was designed for low latency and high throughput network traffic distribution from your front-end request to backend pool. What is the front-end backend? This is your front-end request, all the requests which are coming, and this is your backend pool. This from your backend pool, right? This is a regional service. What do you understand by regional service? We have seen now regional services. What do you understand by regional service?
Like it may be
That is
available in some
connected to.
region and not available in other region.
Not really. Here it means regional service, which means that if a particular region is down, then your service is down. For example, Azure Active
Okay.
Directory. It's a global service. If your East US region is down, your Azure Active Directory is not impacting. Nowadays, it's Entra. Entra ID, it's not being impacted. It's a regional, it's a global service. But Azure Load Balancer, it's a regional service. If you're deploying it in East US, and if East US region is down, then your load balancer is down. Simple. And the another impact of that, if it is a regional service, if you are deploying that in East US region, then you will be able to connect only machines which are there in East US. I cannot have my load balancer in West US and my machines, backend machines from East US. I cannot have my load balancer. Let's say this is my load balancer. This is in East US and these are in West US. That is not possible. Clear? So both of them, they have to be in same region. This is called regional service. Is it clear, guys, to everyone?
Yes.
So if a question arises to you that I have a load balancer in West US and I have 10 machines in East US, will you be able to configure it for me? No, that is not possible. Either you will require machines to be moved to those region, or you have a new load balancer in this region. So that is a regional service. Okay. Next thing is, it is also tagged with a virtual network. What does it mean? It means that if my load balancer it's on virtual network A, then I can have machine in the backend only to machines which are on virtual network A. I cannot go ahead and add the backend machines which are on virtual network B. Similar example, if this is a part of this virtual network, if it is a part of some particular virtual network, then I can add all those machines from the same virtual network only. I cannot go ahead across the virtual networks. I won't even see those machines. If my load balancer is in East US, VNet 1, and if I try to add virtual machines East US, VNet 2, I won't even see those virtual machines. Clear, guys? Still here?
Clear.
Yes, sir.
Any
Yes,
doubt,
sir.
any questions still here? Right, so remember, make sure that you read it properly. This explanation, you get many questions on based on load balancer out of this paragraph. Okay, then we have public load balancer and then we have internal load balancer. I just explained it to you already. What is a public load balancer? Something which is facing on the internet. So it will have a public IP address because your users are outside over the internet. They will require a public IP address. An internal one, it is for internal usage, which are the users are coming from multiple virtual networks, but within the same region, within the same you can say within the same network of Azure, not from the outside, not from the internet. So these are the types, public and internal. We'll see one internal also and we'll see one public. Mostly we are going to see public. Internal is easy, maybe you guys can do that. Now, what are the components of your load balance? This is important question. Understanding in practical, we are going to see tomorrow. We have only 6 minutes left. But from the theory point of view, you should know what are the components. So what are the components, guys? We have one front end on load balancer. We have backend pool. We have health probe. We have load balancing rules. So if I draw this, we have, let's say that this is where I'm planning my load balancer. So we have one front end. Front end is always where my public IP is assigned. So my all users, they can use it. So maybe I will have a front end. This is a component, a front end. This will have a IP. It is called front end public IP. This is one component. Front end public IP. This is one component. Okay. What is the next component I have here? I have here backend pool. So I'll require backend pool. Now, what is this pool? I can have my machines in that backend pool. I can have multiple machines and multiple pools. So let's say that this is my one backend pool. I can have multiple backend pools or I can have single backend pool also. And in that backend pool, we will have all our machines on which we want load to be balanced. Okay. Then what do we have? We have health probe.
Health probe.
Yes, we have health probe here. Now, what is health probe? I'll explain it to you when we start doing the practical. We have only 4 minutes left, so I'm not explaining health probe here, but we have something called health probe. I can just give you a basic idea. What does it do, this health probe? This is where we check. First, let me draw the last component. It is load balancing rule. So we have one component called load balancing rule. So you should know these components at least. Load balancing rules. So now this health probe, what does it do? This is where, this is the place where we define what is the health probe. That what is the benchmark of a server where I can call it alive or dead or working or not working. So the health probe here, this is where we configure that because all these servers I'm running a website on them. So port 80 is very crucial for me. So here I can define that in every 5 seconds, here I can define that in every 5 seconds, you should check all the servers for port 80, whether port 80 is working or not. If there are two consecutive misses, then declare that server as dead. So in every 5 seconds, I'm checking it is sending some network bit or network heartbeat, anything to all servers on port 80. If it gets replied, it will consider that server as on. If it doesn't get any reply, it will consider that server as down. It said this is down. After 2 attempts, not a very first attempt, it will declare it as down. After 2 attempts, it will declare it as a down. So this server, it's down. Okay. Now, similarly, it will do for all servers. And based on this, it will send the traffic. So this is your health probe. In network load balancer rules, this is where it decides that on which port it is going, from where it is coming, which machine it should connect to, all these details. But we'll see this on the portal, load balancing rules. And we'll have to combine this. We'll have to combine the front-end IP, load balancing rule, and health probe. This is how we get our complete solution of load balancer. You will get more clarity when we do the practical tomorrow. We have only 2 minutes left. So I'll finish it for today. We have done the theory part of load balancer. We are going to do the load balancer practical tomorrow. And any other questions or basic task on networking, and we are going to finish our topic networking, finish our segment networking tomorrow. And from next weekend, we are going to start on storage. I will be sending some videos to you guys, some study material, so you guys can have basic understanding of storage, or I don't even have to send it in the same file. Go to Azure this is the section I'm talking about, and then we have page here, like we have Active Directory, subscription, compute, network. Similarly, I have Azure storage. Watch this video. This is very helpful. You will understand what is a database, what is storage, etc. You will understand this thing, at least these many things till here. These are basic storage concepts, and from here the Azure storage starts. So I will be teaching you from here storage durability option, but I'm expecting you guys to know all these options. I've clearly written here, I have put the video. It's very easy, won't take more than half an hour. So do this study maybe next the next week which you have. See you guys tomorrow, same time. We'll do the practical of load balancer. Meanwhile, try to finish your practical on UDR also, guys. Okay, I'm stopping the session. I'll upload the recordings. See you guys tomorrow then.
Thank you.
Thank you.